Okay, so in this sprint, I'm going to be taking a look at the updatable and drawable managers. Before I do that, going over some past comments, I have made a new file called user content where the user can load all of their resources separate from the engine class. And looking at our asset managers, I have added some assert functions to basically help the user identify when they've made a mistake in loading or getting assets. So for instance, if they type in the same custom name for loading an asset, they should get an error thrown there. And then likewise, if they go ahead and after they've loaded an asset, they accidentally mistype the name when they're getting that asset, we should also get an error thrown as well. And then going through each of these objects, it's now the user's responsibility to go ahead and either register the object to be updated or drawn, or both. It really just depends on the object itself. So looking at the drawable manager and the updatable manager is very similar to this. We basically hold on to the list of the objects that are going to be drawn here, and then every frame will go through those list of objects and actually draw it or update it. When we register the object, we'll pass in the pointer for it, as well as hold on to, we'll remember the reference of its place in the list. So when we go ahead and deregister the object later, we just pull that reference back up, so it's a lot easier to get rid of it. And then looking at our updatable class, and again, the drawable class is very similar to this. Taking a look here, we hold on to a reference for our current register state, just to help us identify what state we're in so we don't accidentally double register or deregister the same object. And we also create hold references for our register and deregister commands and use them as many times as we need. And then we'll just delete those once the object itself is actually deleted. And of course, down here we have the different functions either to submit our requests to the scene to be registered or actually go ahead and register them when the time is right. And then looking at our scene class, which has been expanded inside of our update, we will first and foremost check the register broker to execute any waiting commands. We'll also check our alarm manager to find any alarms, and then we'll call our update manager to update any objects that need to be updated in the list. And inside of draw, we'll call our draw manager to draw any objects that need to be drawn. And then inside of our demo scene, now with those update and draw taken care of in scene, the user only needs to initialize and destroy their objects in their own scene. Inside of our registration broker, pretty straightforward. We just add a command into the list, and then whenever we call to execute the commands, we just go through the list, execute each one of them, and then we clear the list. So all of these commands are very similar. We basically just pass in the pointer for the object when we create it, and when we actually execute the object, we'll call its respective register or deregistration function. So going through here then, the demo should still be working as normal. And looking at the debug code down at the bottom, we can also see the messages from our different destructors identifying those objects being deleted.